Hello, this is my presentation on the ever-changing Earth. These are the learning objectives. You can pause and take a look. However, as I'll be going through everything here today, I'll continue. Firstly, we have the Earth and its layers. The Earth is split up into 4 layers, being the solid iron core, the molten outer core, the mantle, and the crust. The solid iron core is around the temperature of the Sun, and due to this was thought to be liquid. However, due to iron and its body-centered cubic structure, it's actually solid. At low temperatures, the BCC is in the structure of a crystalline plane, and due to this, it's able to slide over each other, making it highly unstable. However, at high temperatures, the BCC loses this plane structure and releases large amounts of entropy, which in turn makes it solid. The molten outer core is made up of iron and nickel, and due to radioactive decay from uranium and thorium, it keeps it molten. This also causes movement, which creates an electrical current, which in turn makes a magnetic field around the Earth. The mantle, being the thickest part of the Earth, is made up of mostly iron, magnesium, and silicon. The Earth's crust, which is composed of silica, aluminum, and oxygen, is made up of many pieces of land which we know as tectonic plates. Before the tectonic plate theory began, there was once the continental drift theory, which was theorized by Alfred Wegener. In 1912, he thought that the Earth was once one landmass called Pangaea, and that the continent split and drifted through the oceans. He theorized this as when he was studying fossils, he found fossils of a similar creature in both South America and South Africa, and that creature being the mosasaur. Scientists, however, didn't agree with this, as there was no explanation or mechanism on how the continents were able to drift. This is when the tectonic plate theory arose, and they stated that the tectonic plates were able to move due to convection currents caused by the mantle. Tectonic plates have different interactions with each other. One interaction is the constructive plate margin, which is this one here, and that's when two plates move away from each other and allow magma to arise from the ground, which creates new landmass in the form of a shield volcano. You then have the conservative plate margin, and that's when two plates slide against each other to build up friction. They become stuck, and the buildup of energy is then released in the form of an earthquake. Lastly, you have the destructive plate margin, this one here, and that's when a continental plate, this one, and an oceanic plate, which is this one, collide against each other. Due to the oceanic plate being far more dense than the continental plate, it gets pushed down and melts in the mantle, and is then released in the form of a volcano. 4.6 billion years ago, the Earth's early atmosphere formed, and this is due to volcanic eruption. This volcanic eruption released water vapor, carbon dioxide, and ammonia into the atmosphere. The water vapor which was released condensed as the Earth cooled and formed the oceans. The ammonia which was released was broken down by sunlight, and nitrogen was released into the atmosphere. Due to nitrogen being unreactive, it just built up over the years. As carbon dioxide decomposed into the oceans, bacteria formed. The bacteria use photosynthesis to absorb the carbon dioxide to then release oxygen as a waste product. Due to this, the oxygen levels rose and the carbon dioxide levels decreased. The carbon dioxide levels also decreased due to the carbon dioxide being sealed into fossils. However, due to the burning of fossil fuels, the amount of carbon dioxide being released into the atmosphere has increased again. Carbon dioxide is maintained through the carbon cycle, and that's when respiration and combustion from animals and the burning of fossil fuels release carbon dioxide into the atmosphere, and then photosynthesis absorbs the carbon dioxide to release oxygen back into the atmosphere. Though, due to the amount of fossil fuels being burned, the amount of carbon dioxide and sulfur dioxide being produced is far greater than it being absorbed, and that has led to greenhouse gases. These greenhouse gases in the environment have caused the world to heat up. This is due to heat being trapped into the atmosphere. This has led to global warming, which has led to the melting of ice caps, droughts, and severe weather conditions like hurricanes. There are solutions to global warming, such as reusable energy in the form of wind and solar power, or planting more trees. This has also helped decrease the amount of acid rain, as the burning of fossil fuels releases nitrogen oxide. However, due to their less burning of fossil fuels, there is less nitrogen oxide in the atmosphere. The Earth's air is made up of 78% nitrogen, 21% oxygen, and then 1% of a multiple variety of elements. There are tests to identify for oxygen and carbon dioxide. You can test for carbon dioxide by bubbling it through lime water. If the test is positive, it will turn the lime water milky. This is due to lime water, which is calcium hydroxide, reacting with carbon dioxide to form calcium carbonate. The calcium carbonate, which is insoluble, creates a precipitate which turns the lime water milky. You can test for oxygen by placing a glowing splint into a gas. As oxygen is combustible, it will relight the splint and therefore show that the gas is oxygen. Thank you for listening.